Hello everyone. Today in this lecture I am going to discuss the topic ISDN. So what is ISDN? ISDN is the facility to transfer the digital data using existing telephone lines. So we can say that ISDN is a network in which connections established by digital switching are used for transmission of digital signals. So an integrated digital network ISDN is an integrated digital network in which the same digital switches and the digital paths are used to establish connections for different services. So in the term ISDN, integrated services refers to ISDN ability to deliver two simultaneous connections in any combination of data, voice, video and fax over a single line, and multiple devices can be attached to the line and sent as needed over a single line. So integrated services digital network. What is digital here? Digital in ISDN refers to its purely digital transmission as opposed to the analog transmission of plain old telephone services. So ISDN transmits data digitally, resulting in a very clear transmission quality. So there is none of the static and noise of analog transmissions that can slow transmission speed. So digital refers these things. What is network? So network refers to the fact that ISDN is not simply a point-to-point solution like a leased line. It is different from that. ISDN networks extend from the local telephone exchange to the remote user, and it includes all of the telecommunications and switching equipment in between. So when you have ISDN, you can make connection throughout the world to other ISDN equipment. So if your ISDN equipment includes analog capabilities, you can also connect analog. If your ISDN equipment includes digital capabilities, you can also connect digital. So what are the key points of the above definitions which I have told you? The key points are, first point is the ISDN is an infrastructure to support a wide variety of services and is not a network designed for any specific service. The end-to-end digital connectivity implies that the digitization process begins right at the user premises. It should not be like in the first point. So it should be possible to support every conceivable service on ISDN. For any such service is either a voice or non-voice service. So another point is a small set of carefully chosen interfaces should enable the support of all possible services. The user of ISDN should not be burdened with too many specialized interfaces, but at the same time an expensive universal interface should be avoided. So after this we can say that ISDN is a potential telecommunications standard that is capable of sending digitally encoded voice, data, video and other signals on the same existing line. So this is the ISDN. In the next slide, here it is ISDN services. So what are the services ISDN is providing? So before going to the services, what are the features of the ISDN? So it supports bandwidth of about 2 megabits per second. So it is enough to fill a European E1 transmission channel. What is another feature is it uses a single data link to get the gamut of a user's communication devices such as telephone, fax, it may be computer or video onto the ISDN lines. It provides bearer services for communications, tele services for information processing, and supplementary services. ISDN allows for internal and external switching so that calls can stay within a PBX, private branch exchange, or travel across a vast network to a destination that might be halfway around the world. Okay, so we are going to discuss the ISDN services. So there are two types of ISDN services, and there is supplementary services also. What is bearer service? Bearer services are, it is shown in the diagram, bearer services are concerned with moving information from one location to another. So for this we are using here circuit switching, packet switching, frame switching, and cell switching. These are the techniques for moving information from one location to another location. Several bearers are supported, such as frame relay, X.25, circuit switched. What is frame relay? Frame relay uses fast packet switching and stripped down processing to provide 2 megabits per second throughput. Okay, so what is X.25? X.25 provides packet switched services at modest speeds but with good error handling and flexible routing services. Another bearer services is circuit switched. It connections capable of carrying voice or data at up to the 64 kilobits per second, and even at multiples of this rate, bearer services. Next is teleservices. Teleservices are concerned with processing information in various ways. Teleservices include the following. What it includes? Mixed mode, telefax, teletext, telex, teleconferencing. What is mixed mode? Mixed mode means it allows a combination of text and image, such as facsimile, information to be sent together. What is telefax? Telefax provides fax transmission, store and forward capabilities. Here it is given in the teleservices. What is teletext? Teletext provides text communication capabilities using a standardized alphabet. Telex, which provides interactive communication capabilities. Videotext, which includes capabilities for sending, storing and retrieving text and graphics information. So with this we can differentiate between these two services, bearer and teleservices. So bearer services are concerned with moving information from one location to another, and teleservices are concerned with processing information in various ways. So this is known as teleservices. See, both these bearer and teleservices functionalities may be enhanced by adding to the basic service. The functionalities of what are known as supplementary services. In supplementary services, both the functionalities of the bearer services and tele services are combined and enhanced by some other basic services. So combinedly we can see these are the supplementary services, and supplementary services cannot stand alone and are always offered in conjunction with either a bearer service or a tele service. These are the services provided by the supplementary: call waiting, reverse charging, message handling, telephony, including caller ID, call forwarding, conference calling. These are the services of the supplementary services. Okay, so these are the ISDN services. This is the IDN, Integrated Digital Network. In this diagram it is shown that how it works and how the office is connected to the various packet switch and circuit switch networks through digital pipes, and this telco office in this diagram, how it is connected with the local loop. There are some analog local loops and digital local loops to the computer, to the modem, or to the base phone. How it is connected is shown in the figure. This is ISDN, Integrated Services Digital Network. So ISDN uses the integrated digital networks, and in this diagram it is shown that how ISDN's office is connected through the digital pipes with the packet switched and circuit switched networks, and how these ISDN offices are connected through various subscriber loops to the homes and the offices. How it is connected, it is shown. So there are some interfaces known as BRI, Basic Rate Interface. So basic rate interface, what is basic rate interface? Basic rate interface is the most common service and was intended to be the most widely available for residential customers. In this diagram it is shown how it is connected to the residence. So BRI services provides two, there are some channels are used in this interface, 2 B channels and 1 D channel. So it is written in the in this yellow circle, B1 and B2, B channel 1 and B channel 2, and 1 D channel. So there are 2 B channels and 1 D channel in the basic rate interface, and it provides 2 single 64 kilobits per second channels per line. But when the 2 channels are bounded in a single connection, we get a speed of 128 kilobits per second, which is about 4 times the actual top speed of the fastest analog modems. Okay, so using this basic rate interface, there are 2 B channels and 1 D channel used as a digital pipe, and this is connected to the ISDN office. So here it is calculated that 1 B channel has having capacity of 64 kbps, and 1 D channel is having the data rate of 16 kbps, and 48 is used as an overhead. So total 192 kilobits per second speed can be used in the basic rate interface. Next, this is the PRI, primary rate interface. In primary rate interface, it is used for the greater capacity requirements. So typically the channel structure is, in this channel there are 23 B channels. Here it is numbered B1, B2, B3, B4 to B23 and one D channel. So 23 B channels, and each B channel is having capacity of 64 kbps, and one D channel. There are two types of D channels. One is having capability to 16 kbps and another is 64 kbps, and here it is 8 overheads are used. So total, it is calculated that in primary rate interface the data rate can be 1.544 megabits per second, and this can be used as a channel, and there are 23 B channels and one D channel is used in the primary rate interface, and this line can be connected to the ISDN office. Okay, now the functional grouping. Functional grouping means which type of equipments are being used in the ISDN, or we can say integrated digital network. So ISDN requires different equipments that analog, dial-up or even digital lease line services use. To connect to the internet, our equipment should include, as here it is shown, TE. TE is a hardware that is not compatible with the ISDN, such as telephones, computer, videos and fax machines. So TE2 equipment is connected over an R interface to the terminal adapter, which makes the incoming signals ISDN compatible. Okay. What is TA here? Terminal adapter. These are the terminal adapters. What are the NTs here? Network termination device. What is NT? The NT1 is a relatively simple device that serves as an interface between the ISDN, basic rate interface line, and our other ISDN equipment, and converts the 2-wire U interface into the 4-wire ST interface. There is another network termination 2 NT2 device which converts the T interface into the S interface, and finally it is connected to the ISDN office. In this is ISDN layers: physical, data link, network, transport, session, presentation and application. This is similar to the layers of the ISO OSI model, Open System Interconnection model. In these layers, one is user plane and another is control plane, and this is commonly known as management plane. So each and every layer has its own function, and these functionalities are applied on the data which is going to be transmitted. Okay. So this is the simplified layers of the ISDN, B channels and D channels. What is physical layer here? In physical layer there is two interfaces, basic rate interface and primary rate interface. In the data link layer there is LAPD and others, and LAPD. Okay. What is LAPD? LAPD is the link access procedure on the D channel, and LAPB is link access procedure on the B channel. There are two different channels, so these two are shown here. For the network there is X.25 and others for the B channel, and for B channel there is call control Q.931. And for the layers 4, 5, 6, 7 in B channel there is user's choice, and in D channel there is end-to-end user signaling. Okay, so there are, for the broadband ISDN, integrated services digital network, there are two types of services: interactive and distributive services. In interactive services, the user can initiate this service and influence its direction. So three classes are distinguished, and each class includes several examples. For example, conversational service include video conferencing and video telephony for shopping and learning requirements, and online research is included among interactive services. So this is interactive services. What about the distribution services? Yeah, distributive services. Distributive services are those in which information, which type of information, in the form of video, documents or data, can be broadcast to whoever has the resources and rights to receive the broadcast. Distribution services are divided into those for which the user has no control over the presentation, and those where the user can control which elements are received. Examples of former include TV programming, electronic newspapers. An example of latter means distribution services includes the retrieval of selected news items and certain online courses. So this is the broadband ISDN. So broadband ISDN supports 155 megabits per second data rate. So broadband ISDN is an extension of the ISDN, and it allows multiple types of information to be transmitted. It can handle voice, video and graphics as well as data, whereas simple ISDN network generally use some form of time division multiplexing for actual transmission. So what we do in the time division multiplexing, there are several machines, several stations. Each and every station has its own data. So some specific time slot is allocated to all the devices, so that in its time slot only that device can send data. So there is no conflict. Broadband ISDN network generally use ATM, asynchronous transfer mode, as their transmission technology. So for transmission technology it uses asynchronous transfer mode. Okay, so this is the broadband ISDN. This is broadband ISDN accesses. There are 155.520 megabits per second capability. There are some more other data rates are available in the broadband ISDN for the office purpose. Okay, so if we compare the narrow integrated services digital network and the broadband integrated services, there are two types of ISDN: narrow band and broadband. So if we compare between these two, the narrow band ISDN supports 64 kilobits per second data rate. But in the case of broadband ISDN, it supports 155 megabits per second data rate. So this is the almost more than double the data rate. The bandwidth of narrowband ISDN is quite low in comparison to broadband ISDN. So bandwidth is quite low. The bandwidth increases of broadband ISDN is by a factor of 2500 over narrow ISDN. So in narrowband ISDN it works on the circuit switching technology, but in case of broadband ISDN it is based on ATM technology, which works on packet switching. So packet switching is used in the broadband ISDN. Narrowband ISDN consists of twisted pair wiring, twisted pair cables, but in broadband ISDN it cannot be sent over existing twisted pair lines. What are the examples? What are the services which are used in the narrowband ISDN? So examples are caller identification, call conferencing, remote electricity meter reading, online medical help, security alarm, call forwarding. There are many more applications of the narrowband ISDN. But what about the broadband ISDN? What are its applications? High resolution, video on demand, live television, high speed data transport on telephone lines, full motion multimedia electronic mail, and CD quality music, etc. There are so many broadband ISDN examples. So we can say that broadband ISDN is much better than narrowband ISDN in various ways. So narrowband ISDN was an initial step in the digital age, and broadband ISDN is a bold leap into the unknown. A very high data rate and high bandwidth utilization makes broadband ISDN better than the narrowband ISDN. Also, its ATM technology and the advanced services contributes in the better performance. So this is the all about of ISDN, Integrated Services Digital Network. Thank you.